In Lesson 5-6, Day 1, you will solve and graph inequalities in two variables. The ones that you will be working on this day will already have them in slope-intercept form. Here are the steps for solving inequalities in two variables. First, you need to put it in slope-intercept form if it isn't already. The ones that you'll be working on tomorrow in class will already be in the form of y equals mx plus b, but instead of an equal sign, it'll have an inequality symbol. Then it's going to be very similar to Chapter 4, where you graphed equations in slope-intercept form. We're going to do the same thing here. We're going to plot the y-intercept, which is b, and use the slope, m, to find another point. And then you'll connect them, but you'll have to decide if the boundary line is going to be solid or dotted. If it's a less than or greater than symbol, it'll be a dotted line because it will not include the points on that line. If it's a less than or equal to or a greater than or equal to, you will use a solid line because the solution will include the numbers on the line. Then the new part, you will need to choose a point to test to see if it is part of the solution or not, and then shade the correct half of the graph. Because basically the line, when you plot your y-intercept and use your slope to find another point, and then when you connect those, that's like your boundary line, and the solution is either going to be the points above it or below it. And so if you test a point, you can see if it works in the solution to see if it's part of the solution or not. You'll see what I mean when we get to some examples. Our first example is y is less than 2x minus 5. So we're going to start by graphing the line y equals 2x minus 5 by plotting the y-intercept, which is negative 5. So we're going to go on the y-axis to negative 5 and put a point. And then the slope is 2. And since it's a whole number, we're going to write it as a fraction. And we're going to rise 2 and run 1. So rise 2, run 1. Rise 2, run 1. Rise 2, run 1. And now when we connect this, we're going to connect it with a dotted line because this symbol here says it does not include the numbers on that line. So we need a dotted line. And arrows on both sides to show that it keeps going. Now the solution is either going to be the numbers over here or the numbers over here. So what you're going to want to do is test a number. I like to test 0, 0 just because it makes the math really easy. I'm going to plug in 0, 0 and see if that's a solution to this inequality or not. So I'm going to plug in 0 for y and for x. So is 0 less than 2 times 0 minus 5? Well, 0 less than 2 times 0 is 0, and 0 take away 5 is negative 5. Is 0 less than negative 5? And that is no. So 0, 0 is not part of the solution, so therefore we don't want to color this half of the graph, we want to shade in the other half of the graph. So all of the points that are on this side of the dotted line are solutions to this inequality. So you could pick any ordered pair in this shaded region, plug in the ordered pair to the inequality, and it should work. It should be a true statement. Next example. Once again, we're going to graph the boundary line first. We're going to graph the boundary line by looking at the equation y equals negative 3x plus 1, which means the y-intercept is at 1. So I'm going to go to positive 1 on the y-axis. And then the slope is negative 3. So we are, instead of rising 3, we're going to fall 3 and run 1. So we're going to, from that point, go down 3 and to the right 1. Down 3 more and to the right 1. Down 3 and to the right 1, and so on. Instead of going down 3 and to the right 1, you could go up 3 and to the left 1. As long as you go in a negative direction once for a negative slope, you're going to end up in the right spot. This time when we make the boundary line, it's going to be a solid line because it has this equal sign along with the less than. So it's less than or equal to the points that are on this line. Arrows on the ends to show it keeps going in both directions. And now we need to figure out which side of the graph to color or to shade in. So I'm going to test 0, 0 again. I'm going to test this point right there. If I plug in 0, 0 for x and y, I get 0 is less than or equal to negative 3 times 0 plus 1. Well, negative 3 times 0 is 0, and 0 plus 1 is 1. Is 0 less than or equal to 1? It is. So therefore, we know that 0, 0 is part of the solution, so we want to shade the half of the graph that has 0, 0. So we're going to shade this part over here. All of the points that lie in this shaded region would be a solution to this inequality. All right, next we have y is greater than 5. When you only have a y in your equation, or in this case inequality, you're going to have a horizontal line that goes through the y-axis at 5. Because it's a greater than, it's not going to be a solid line, it's going to be a dotted line. Put arrows on both ends to show that it keeps it going in both directions. And now we want the numbers greater than 5. So all the numbers y that are greater than 5 are up here above the line. So we're going to shade this part up here. Now in our last example, we have x is greater than or equal to negative 2. Since this one only has an x, instead of it being a horizontal line, it's going to be a vertical line, and it's going to go through the x-axis at negative 2. Remember, when you only have an x or only have a y, it really looks the opposite of what you might initially think, because the x-axis is horizontal. It's not going to be a horizontal line, it's going to be a vertical line going through the x-axis at negative 2. This time it's going to be a solid line because it is a greater than or equal to. So solid line going through the x-axis at negative 2. Arrows at both ends. And this time we want the numbers greater than or equal to negative 2. So all of the x numbers that are greater than or equal to negative 2 are going to be to the right of that line. So all of these points over here have x values that are greater than or equal to negative 2. No! What happened? Ah, there. Now